Hello everyone, welcome back to maths class, chapter number 25, probability, the continued part of exercise 25C. Next it is question number 21. 7 cards, the 8, the 9, the 10, jack, queen, king and ace of diamonds are well shuffled. Even though this question is of playing cards, children, it is not a question with playing cards of 52 but it is standard format. Here they have taken few cards, that is how many cards they have taken? 7 cards. So let us list out which are all those 7 cards. 8, 9, 10 the number cards and the jack, queen, king and the ace. All these belongs to diamond category which is not required for us. As they said there are 7 cards, total number of all possible outcomes will be equal to 7. Now the question is, one card is picked so that what is the probability that the card drawn is the 8 or the king? 8 or the king. How many 8 cards are there? Only 1. How many king cards are there? Only 1. Hence 1 plus 1 is equal to 2. Required probability is equal to 2 by 7. Second sub question is, if the king is drawn and put aside. So now we have 7 cards. Among that, king is drawn and it is kept aside. Then what happens at this situation? We are going to have only 6 cards. That means king is excluded from the group. Now when I am having 6 cards, that is here they said if, that means this particular situation is applicable only for this sub question too. So out of 7 cards, if king is removed, then what is the probability that the second card picked up is an ace? Now we had 7 cards, king is drawn and removed, hence the total number of cards are 6. Among the 6, how many are ace? It is only 1 card, that is equal to 1 by 6. And the second sub question says a king. How many king cards, children, out of 6? Do we have any king cards? No, we had only 1 king card when there were 7. Or as already we have removed 1 king card out of 7 cards, then the number of king cards are equal to 0 and the required probability is 0 by 6. Its value is equal to 0. Next, question number 22. A box contains 150 bulbs, out of which 15 are defective. So we have 150 total bulbs, 15 are defective. It means to say 135 are good ones. As the total number of bulbs is 150, total number of all possible outcomes is also equal to 150. The first question is, calculate the probability that the ball taken out is a good one. How many good ones are there, children? 135. Hence the probability is 135 by 50, which is equal to 9 by 10. In a similar way, under sub question 2, it says, what is the probability that the bulb taken out is a defective one? How many defective bulbs are there? 15. Hence the probability is 15 by 150, which is equal to 1 by 10. Next, question number 23. 4 defective pens are accidentally mixed with 16 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is drawn at random from the lot. What is the probability that the pen is defective? So 4 defective pens are accidentally mixed with 16 good ones, means we have 20 pens, among them 4 are defective and 16 are good ones. Hence the total number of all possible outcomes is equal to 20. And in the sub question 1, it is asked to find what is the probability that the pen is defective. We have 4 defective pens out of 20, hence the probability is 4 by 20, which is equal to 1 by 5. And the second sub question is somewhat similar to question number 21. Suppose the pen drawn is in 1, that is the first sub question, is defective and is not replaced. See children, method is same, situation differs. Out of 20 pens, among them 4 were defective. Now a defective pen is drawn and it is not replaced. Then what happens? Out of 20, the total number of balls is reduced to by 1. Hence the total number of possible outcomes is 19. And which ball is removed? Which pen is removed? That is nothing but defective pen. Hence the number of defective pens is also equal to 4 minus 1, which is equal to 3. Now after removing a defective pen from the given pens, what is the probability that the pen drawn is a defective? So number of favorable outcomes is 3 because out of 4, 1 pen is removed. So now we have only 3 defective pens and the total number of balls what we have is equal to 19. Hence the probability is 3 by 19. Not defective one, that is 16 balls, 16 pens. We had 16 good pens, probability is 16 by 19. By this we have completed the questions up to question number 23. Thank you children, have a nice day.